In today's video, we're going to look at combining functions. So we're going to look at adding, subtracting, multiplying and dividing different functions together. Okay, so if I define f and g to be functions, so I've got two different functions, f of x and g of x, then if I want to add them together, I'm actually going to define that as f plus g of x, and that is just where I add the two together. So I get this new function f plus g of x by adding f of x and g of x, and I get this brand new function out. Similarly, I get the brand new function f minus g of x by subtracting g of x from f of x. Multiplying works in a similar way, so I've got f multiplied by g of x is just f of x multiplied by g of x. And then dividing has one other property that we need to be aware of. So if I create this new function, f over g of x, that is just f of x divided by g of x. But we have to make sure that g of x does not equal 0, because otherwise we cannot divide by it. We cannot divide by 0 when we do math. So we need to make sure that g of x does not equal 0 when we do this division. I'm going to do a couple examples here, and then we're going to move on to look at domains once I've done this. So for my first example, I'm going to take the two functions f of x is equal to 3x plus 1 and g of x is equal to x squared plus 6x plus 5. And in this problem, I'm going to find the two functions f minus g of x and f over g of x, because there's a few things that I want to look at here in particular with these two different functions. So if I do f minus g of x, to find that I just do f of x minus g of x. So that would be 3x plus 1 minus my whole function g of x. Now, the thing that I want you to be aware of with this, because we're subtracting that whole function, I've got to distribute that negative. So I get 3x plus 1, and then I have to distribute it across all the terms. So that gives me minus x squared minus 6x minus 5. And then I'm going to rearrange and simplify. So I've got my x squared term goes first, then I've got 3x minus 6x gives me negative 3x, and then I've got 1 minus 5 gives me negative 4. Then I'm going to find f over g of x. So f over g of x is just f of x over g of x. Okay. So my f of x function is 3x plus 1, and my g of x function is x squared plus 6x plus 5. Okay. Now there are going to be points normally where this denominator will equal 0. So that's something that we have to be aware of, and that's going to come up when we look at our domains. But the function itself is not 0, so we're fine right now. But if you ended up with g of x was actually the constant function 0, then you know that, of course, this cannot happen. We cannot do this division of functions. But when we look at domains in a second, we're going to want to look at where does this denominator here equals 0. Where is this function undefined? And that will help us find the domain of the function. So in order to do that, what I'm going to do is simplify this or rearrange this in some way so that we actually have that denominator factored. That will help us down the road. You can figure out however you want to factor this. It's completely up to you. You are looking for two numbers that are going to add to this number and multiply to this number. So I want two numbers that add to 6 and multiply to 5. Well, that's going to be 5 and 1. And that tells me that my factorisation here is going to be x plus 1, x plus 5. You can then go ahead and actually multiply that out and you should get the same thing back. This works if you have a coefficient of 1 in front of that x squared. You could just look for two numbers that add to that coefficient and multiply to this constant at the end. Okay? So I'm going to leave that function like that for now, and we will come back to it when we look at domains in a second. I'm going to go ahead and do one more example before we go ahead and do that, and look at some other things with tables, etc. So the next thing that I want to look at is if both f of x and g of x are fractions. I want to make sure that everyone is comfortable in dealing with these fractions. Okay. Couple ways you can deal with this depending on what the problem asks. First thing I'm going to look at is what is f over g of x. So we know that that's f of x over g of x, which would be x over x plus 3 over x minus 2. Okay? So I have a fraction divided by a fraction. We know that when we divide by a fraction, we can flip the bottom fraction and actually multiply. So this is the same thing as saying x over x plus 3 multiplied by x minus 2 over x. So I've flipped that bottom fraction and I've multiplied. Then I can see that I have the x's here cancel, and I am left with x minus 2 over x plus 3. We're going to come back to this example again when I look at domains, because there's a couple of things that we have to look at. So I really like this example as well when we look at domains. The last example I want to go through before that is looking at a table of values. Okay. So, for example, if you are given values of x and f of x, and then again x and g of x, I want you to know how to find f plus g of a particular x value, or f minus g of a particular x value. So I'm going to create some x values here. Let's have 0, 1, 2, 3. And again, I'm going to have 0, 1, 2, 3. And I'll say that f of x in this case is going to be 6, 9, 12, 15. And here I'm going to have 2, 8, 14, and 20. Okay. And I'm going to look at what is f plus g of 0. Okay. So I'm looking at what is this new function f plus g at a particular value. So I'm evaluating f plus g at a particular value. I don't know what f and g are in terms of the actual functions. I only know what values I get back from the functions when I plug in a particular x value. And that is all I need in this case, because I know that f plus g of x is just f of x plus g of x for any x. So I know that I can then just write f plus g of 0, 0 is just a particular x value, as f of 0 plus g of 0. Now f at 0 is 6 and g at 0 is 2. So that tells me that f plus g of 0 is 8. Okay. And similarly you can do f multiplied by g at, we'll do 0 again. Okay. That's just going to be f of 0 multiplied by g of 0, which is 6 times 2 which is 12. So that's another type of problem that you can get where you're actually looking at these functions evaluated at a particular value. Now we're going to move on to look at domains of these particular combinations of functions. For 3 of them it is very simple, but of course that division that we have, that f divided by g at x, that function is going to give me some issues in terms of the domain, because we've got to be aware of when that g of x is 0, because that's going to then make our function undefined. So for the most part, I'm going to say that D is the domain. So whenever you see a capital D, that means domain. The domain of f plus g, the domain of f minus g, and the domain of f multiplied by g are all the same thing. It is just the domain of f of x intersected with the domain of g of x. What does that mean? I look at where f of x is defined, I look at where g of x is defined, and then I take where those two sets overlap. I'm looking at the intersection, it's where those two sets overlap. So if this is the domain of f of x, and this is the domain of g of x, then the domain of f plus g, f minus g, or f times g is just all points that exist in both sets. So it's any points where they overlap. The issue that I have is where I look at the domain of f over g. Okay. I do the same thing again, but I have an added thing onto this. So it's the domain of f intersected with the domain of g of x, but then I have to take out some values. So I'm actually going to take out, I'll call it minus for now, but I'm going to take out any x such that g of x equals 0. So I'm taking out all x values, all real x values, such that g of x is 0, because that is all x values such that that denominator function is going to give me 0, hence f over g is going to be undefined. I'm going to go back to our other examples and then look at the domains of those, because they are very interesting functions where there's something that we have to be aware of in each case. So starting with this particular example, I'm going to look at the domain of f minus g of x, and I'm going to look at the domain of f over g of x. Okay? We'll do this in a different colour. So in this case, the domain of f minus g, okay, it's just the domain of f intersected with the domain of g. Now both f and g in this case are polynomials, which when we looked at the domain in our last video, we said that the domain of polynomials is just all real numbers. So in this case, both of my domains are all real numbers, hence the domain is just, again, all real numbers for f minus g. Okay, because you can see here, I end up with another polynomial. There are no points for which this is undefined, therefore my domain is all real numbers. Now I have the issue of looking at f over g of x. And this is where I said that earlier we factored it because it was going to help us down the road. We didn't have to for this particular example of just finding f over g of x, but it does help us when we look at this domain. So when I'm looking at the domain of f over g, we said it's the domain of f intersected with the domain of g, which we've already figured out is all real numbers, but I've got to take out any x value such that g of x equals 0. So I've got to take out any value where x squared plus 6x plus 5 equals 0. Okay? All I'm doing there is I am solving a quadratic and finding the solutions to it. And the way that you do that is either by using the quadratic formula, or you can do it by factoring. So that's why earlier I factored this polynomial, because now it's easier to see where x will give me a 0 value for g of x. So in this case, my polynomial equals 0 if either x plus 1 equals 0 or x plus 5 equals 0, which tells me that x is equal to -1 or x is equal to -5. So my domain is just all real numbers except for -1 and -5. You could also do this in set notation if you wanted to, so you could say that it was the set -infinity up to -5 but not including -5, union -5 to -1, union -1 to infinity. So I've just taken out -5 and -1, and then it's all real numbers outside of that. If I go to my next example here, this is where this domain gets slightly more tricky. So here, I am looking at f over g of x. Let's say I want to find the domain. I'll do this on a new slide. So for our example, I want to find the domain of f over g of x. I want to find the domain of this function. But bear in mind, we are relying on our original functions f and g. Okay. So in our definition, we said that the domain of f over g is going to be the domain of f of x, intersect with the domain of g of x, and then take out any values such that g of x is 0. Okay, so what is my domain of f of x? Well, it's going to be all real numbers except where my denominator is 0. So it's all real numbers except for -3. What's my domain of g of x? It's going to be all real numbers except for where that denominator equals 0, which is when x is equal to 2. So I've got all real numbers except for -3 and all real numbers except for 2. Taking the intersection of those two is going to be all real numbers except for -3 and 2. Okay? As long as I don't have x equal to either of those two values, both f and g are both defined. Okay? So I have to take out both -3 and 2 at the start, because otherwise at least one of my functions is not going to be defined. So to start with, I already know I've got all real numbers except for -3 and 2. But remember, I also have to take out any value for which g of x equals 0. So any value of x such that this equals 0. So if I look at where x over x minus 2 equals 0, okay, it doesn't matter what my denominator is as long as it's not 0, and we've already dealt with that. But if you make a fraction equal to 0, you are just looking at where does that numerator equal 0. Well, whenever x is equal to 0 in this case, my numerator is always equal to 0, because x equals 0. 0 divided by anything is still 0. So in this case, where x equals 0, my whole fraction equals 0. So all you have to do whenever you set a fraction equal to 0, just look at where the numerator equals 0. That will make the whole fraction equal to 0. In this case, our numerator is just x, so that tells me x is equal to 0 will make my whole fraction 0. So I also, in my definition of my domain, I also have to take out the value 0, because that is where g of x is equal to 0. So this part here is where the domain of f intersects the domain of g, and then I've taken out here any value x such that g of x equals 0. Okay? So if I put this all together, it's all real numbers except for -3, 0, and 2. That is my domain of f over g of x in this case. Go ahead and take a look at this again. Make sure that you are comfortable with how we find the domains, especially for that f over g of x, because I know that that can be kind of complicated. And just let me know if you have any questions. I'd be happy to go through a couple more examples with you, and then you can look at the examples that come up in the homework and try those. And I'll see you in the next video.